first thing, I'm just going to write this in order of what you do first. You start with your end statement, which is this guy. Then you do these three, and those three don't have to be in any particular order, but you want to do your ands first. So it starts with your and statements. Then you do your or statement, and then finally do your singles, because you subtract after the fact. So you can do this 5, 6, 7, and then you do your individual ones after that. So that's typically how we want to do a Venn diagram when we have three pieces or three circles on the diagram. Now it tells you this on page 72. A intersection B, or sorry, A and B and C is represented by region H. A and B is represented by the union of regions E and H, A and C, B and C. So when you're doing all of this, to get your absolute total of all of everything that's inside the actual Venn diagram circles, they give you a big long equation. So how do I find out how many values are in A, B, and C all together? So that reads, I want the number of A, union B, union C, which is A or B or C. So we want to collectively get all of those values. So to begin with, we take each individual value. So A plus B plus C. Now again, because the n is on the outside, that is just talking about the number in A, the number in B, and the number in C, not what's actually in the set itself. So we add those together. But then we have to subtract, where we have A and B, where we have A and C, down here, where we have B and C. So we have to subtract this region here, and this region here. So we have to subtract those in order to get it. It'll make sense in a second as to how that looks. So then, the final step then is to, if I subtract, like so what I'm doing is I'm trying to attempt to find out how many are in all three of these circles. So this being A, B, and C. So I want to find out how many values are in those circles. Not what they are, but how many are in each circle. Okay? So I start by taking all of A plus all of B plus all of C. So that includes everything in there. And then I got to subtract this and subtract this from my totals because those are combined together. All right? And then I got to finally finish by adding up what's in here. So the final step then is A and B and C. Okay, so that's the middle guy. A intersect B intersect C, or A and B and C. So this is just an equation that's used to help find a particular value if it's not given to me in the actual question. Okay, so let's have a look at the example so we can make more sense of this particular question. Use the following class to answer the question, or clues, sorry, to answer the questions below. In a grade 12 math class, 25 students have a tablet, an MP3 player, or a cell phone. 15 students have a tablet, 14 students have an MP3, 13 students have a cell phone, 5 students have a tablet and an MP3, 4 students have a tablet and a cell phone, 2 students have an MP3 player and a cell phone. How many students have all 3 devices, and how many students have only 1 device? Okay, so let's set this up then. Here's your cell phone. Here's your tablet. Here's your MP3. Okay. So this one gives very specific. Now normally what they'll do is they'll give you they'll give you what the middle guy is, and then you have to work backwards on this. But this one, they're going to give you all the information but the middle guy. So we're going to utilize this equation here. All right, I call it an equation, but realistically it's not. It's just a statement that will allow us to solve for the middle here. Okay, so first things first. 25 students have a tablet, MP3, or a cell phone. So that's total in the class. Okay, so when I'm done looking at this, these three circles should add up to 25. As long as nobody has, or one person doesn't have any of them. But in this question, it doesn't state that. So now what I got to do then is this. 15 students have a tablet, but I don't want to start. Now remember what I just finished saying at the start of the class today? Where do I begin? I got to begin with my and statements. All right? And then I do my or, and then I do my individuals. So let's go to that now. Let's go to that now, and let's do the and statements. 5 students have a tablet and an MP3 player. Tablet and MP3. 4 students have a tablet and a cell phone.
Tablet is not there.
Oh, wrong one. Good. Good. Okay. 2 students have an MP3 and a cell phone. So far, so good. Okay. I don't know this. Right there. Okay. So now, if I knew what this was here, this middle one, and it says how many have cell phones?
13.
13 have a cell phone, right? So I've already got 6, okay, in here. So I got to find out, if I knew this, then I would subtract 13, I would subtract 6, and whatever x was, and the rest would have just a cell phone. That's normally how I would do this question. But right now, I can't do that question because I don't know what that middle is. So I want to find the middle. Well, what did they give us? Well, they actually gave us this guy right here. They gave us 25, did they not? 25 students in the math class. So let's work this backwards then. So let's go 25 equals. All right? How many have a cell phone? 13. How many have a tablet? And how many have an MP3? 14. Subtract. Okay? So, subtract cell phone and tablet, 4. Subtract cell phone and MP3, 2. Subtract tablet and MP3, 5. And then I have to add my middle, because all of that's going to equal 25. All right, now you're just doing simple math, right? 28, 42, 38, 36, 31. So I have does that look all right? Okay. I got an error. What is my error? I'd end up with a negative, right? Okay. So, what did I do wrong then? A and B. So when I did the cell phone and I believe the tablet, I assumed that it was just this guy here, right? But it isn't. The cell phone and the tablet is all of that. So when I do this again, I have 13 plus 15 plus 14, right? Subtract. Now this guy will be, sorry? That's right. X plus 4, subtract x plus 5, subtract x add 2 plus x. Okay? I have to include that x with all the and statements. So now when I do it, I have 25 equals 42 minus x minus 4 minus x minus 5 minus x minus 2 add x. Okay, so far? So I just distribute the negative through those three brackets, right? Okay, so 42, subtract 4, subtract 5, subtract 2. 31, was it not? Okay. Minus x, minus 2x, minus 3x, plus 2x is minus 2x. Minus 1 plus minus 1 is minus 2. Minus 3 add 1 is minus 2. So far, so good. Now when I subtract this, I get minus 6 is equal to minus 2x. What does x equal? X is equal to 3. So how many of those 25 students then has all of the 3? 3 of them. Pardon me? I'm going to try that again, Jake.
I was looking at their own questions. Practice started with 1.
Okay. So I'm okay then? Nice. Okay. So I go back to here. That becomes 3. Okay. How many cell phones did I have? 13. Subtract 9. That means how many has just cell phones? 4. Right? How many tablets were there?
14.
How many?
14.
15. Tablets?
Yeah.
Tablets is 15, right? Okay. So subtract, what, 12? And then 14 MP3s, subtract 10. There you go. So we filled it in. So the second question was, how many students have only one device? How many? 4 plus 4 plus 3, right? Each have one device, so there's 11 of the 25 only have one device. Which means that 14 of the other of the class of the 25 have at least 2 devices. Okay? Any questions about that guy? It's just going to take you 2 questions and then you'll have it nailed. Alright? Okay. I want to look at 3.5 today as well. And probably 3.6 a little bit as well. That way we have it caught up for the rest of the week. Okay, now we are going to look at what we call true statements. Now, in order to do this, the biggest thing that you're going to need for your cheat sheet is going to be writing out all of the different words and what they mean. There's about 5 or 6 of them that you're going to need to know. Okay? So I will highlight them for you, and then you'll go back and you'll do it. Now, a conditional statement. A conditional statement reads, it's basically an if-then statement. If this happens, then this will happen. That's what a conditional statement is. Now, that's your original statement. Your conditional statement is your original statement. If it is Saturday, then I will go to the movies. That's a conditional statement. Okay? So a conditional statement consists of a hypothesis P and a conclusion Q. If it's Saturday, P, then I go to the movies, Q. If P, then Q. P represents your hypotheses. Q represents your conclusion. Everybody understand? So P is your hypothesis. Q is your conclusion. Okay? Now, there's three ways in which we can write this out. We can write it out in words. So, if P, then Q. We can write it as P implies Q. Or you can write it with symbols. That reads P implies Q as well. So the arrow means P implies Q. My hypothesis implies my conclusion. All right. So here's the first of the words that you have to know. To write the converse of a conditional statement, switch the hypothesis and the conclusion. So the converse, word number one. Switch P and Q. So the converse statement reads, if Q, then P. If I go to the movies, then it's Saturday. So the converse. Now you got to remember, there's going to be converse, there's going to be contrapositive, there's biconditional, and there's another one there. What's the other one? Converse, contrapositive, and inverse. So we need to know all of the differences between them. Okay. A conditional statement is either true or false. A truth table for a conditional statement, P implies Q, can be set up as shown. Note, a conditional statement is false only when the hypothesis is true and the conclusion is false. Otherwise, the conditional statement is always true even if the hypothesis is false. Okay, so looking at the truth statement, P and Q. If the hypothesis is true and Q is true, the conclusion is true, then P implies Q is true. Okay? If P is false and Q is false, the statement's true. So I'm looking at this little box on page 76. You should be too. All of you. If P is false and Q is true, then the statement is true. If P is true and Q is false, then the statement P implies Q is false. So that little box there tells you when you write a statement up, a conditional statement, the only time the conditional statement becomes false is if the hypothesis is true and the conclusion is false. Otherwise, it doesn't matter if the hypothesis is true or false, or the conclusion is true or false. It's only when the conclusion is false and the hypothesis is true does that become false. For P implies Q. If a conditional statement and its converse are both true, you can combine them to write a conditional statement using the phrase if and only if. This is written symbolically as implies both ways. So a biconditional statement. A biconditional statement occurs when P implies Q is true and Q implies P is true. When you can write them both ways and it's true for both statements. So a biconditional statement means that if P implies Q and Q implies P are true. implies Q and Q implies P are both true, you have what we call a biconditional statement, and you rewrite it like this. P, arrows pointing in both directions, and it's said to be if and only if. If and only if P implies Q and Q implies P does this work for a biconditional statement. Okay, so let's look at the example that's going with this. The conditional statement is, if it is Saturday, then I will go to the movies. So we need to verify when this conditional statement is true or false and confirm your results with a Venn diagram. We don't need to confirm it, but we're going to talk about it anyways. Okay, so if it is Saturday, then I'll go to the movies. So what is the hypothesis in this statement?
If it's Saturday,
If it's Saturday, what's the conclusion of the statement? I'll go to the movies. Okay, so we've identified that. So if it is Saturday, then it applies that I'll go to the movies. I considered each case for truth or falseness. Since the hypothesis is true or false and the conclusion is true or false, there are 4 possible cases. All right? So case number 1, if it is Saturday, that's true. Let's say it's Saturday. Okay? Then I will go to the movies. So I can either go to the movies or not go to the movies. So if I keep my promise, it says I'll go to the movies. That means that both statements are true. Okay? Then the whole thing is true. Better yet, let's look at this differently. Here's my statement. If it is Saturday, then I will go to the movies. Okay, so let's look at all the scenarios that could possibly happen here, and let's talk about the one that's false. Okay, first of all, it's either Saturday or it isn't, so that's true or false, right? The second thing is, the conclusion is, either I did go to the movies or I didn't go to the movies. So that can also be true or false. We agree? So it sets up exactly like your truth box right here. Same way. What is the one instance in which the statement is false?
if it's Saturday, we can go to the movie.
Exactly. If it's Saturday and you chose not to go to the movies, that's the only time the statement can be false. Every other statement is true. If it's Saturday, true. If it's not Saturday, false. Doesn't matter whether it's you go to the movies or you don't. As long as this is true and this is false, the whole statement would be false. Okay? And so they draw the diagram there. Your hypothesis is inside your conclusion. If it is Saturday, P, I go to the movies, Q. And then there's outside the box is it's not Saturday and I don't go to the movies. Okay, let's look at example 2. Determine whether the converse of the conditional statement in example 1 is true or false. Okay, so what's the converse of this statement then?
Switch P and Q.
Right. So how would that read?
If I go to the movie, it's Saturday.
Yes. Okay, perfect. If I go to the movies, it is then Saturday. So there's the converse of the statement. Okay? So what is the only situation in which that is not true?
If it were any other day.
Pardon me?
If it were any other day.
If it were any other day and you went to the movies. Okay? So that's the only way that this can be a false statement, is if you go to the movies and it's not Saturday.
So our opposite is going to be right ones.
Okay, so it said determine whether the converse of the conditional statement in example 1 is true or false. So I wrote it. I assume the hypothesis was true and looked for a counterexample. It could be that I went to the movies on Tuesday. This counterexample proves the converse is false. So basically all you're doing is you're just rewriting statements for right now. Okay? And checking to see their validity, whether they're true or false. Alright? And all the options that there are for it. So flip over to page 80. Again, I'm going through a lot today. So far, I have a conditional statement. Which is P implies Q. P is my hypothesis, Q is my conclusion. The converse of this is what? Q implies P. The biconditional is written as that. Okay? As well as the converse of a conditional statement, the inverse and contrapositive of the statement can also be found. To form the inverse of a conditional statement, negate the hypothesis and the conclusion. Okay, so the inverse of this, not P implies not Q. That line in front implies not. So not P implies not Q. So the statement that we just looked at, if it's not Saturday, then I don't go to the movies. That would be the inverse of that statement. If it's not Saturday, then I don't go to the movies. That's the inverse. Does everybody understand that? So it's just, the inverse of it is negating both of them. To form a contrapositive of the conditional statement, exchange the negatives of the hypothesis and the conclusion. So the contrapositive then is okay. It works with the converse. The contrapositive works with the converse. Easiest way to remember that. Not Q implies not P. If I didn't go to the movies, then it's not Saturday. On that same question. A conditional statement and its contrapositive have the same truth value. That is, if one is true, the other is true, and if one is false, the other is false. The same is true for the converse and the inverse. So all you're going to be asked to do for the next couple days is rewrite truth statements and do the truth tables, as they've done in the example on page 80. Okay? So I'll look at 3.6 tomorrow with you, and I'll go back through them. The biggest thing is making sure that this whole page here you have down on your cheat sheet. Because if you don't have it down, then it's inexcusable to get it wrong. Right? You get to put whatever you want on there. This should be on there. Okay? Along with the equation for Venn diagrams, which you got in 3.4. That should also be on that sheet as well. Any questions here today? You can expect to get this done by the end of the week. 3.4, 3.5, 3.6, review, and pre-test will come to you by Friday. More than likely Tuesday. Got it? Okay. You got lots to do. Good at it. Bodie? You're over here. So you can actually make this whole work.
Okay, so like
Yeah. Yeah. Yeah.
Why you putting so much work? Put quite a lot on brain.
Because you guys didn't do anything at the end of last week. You did nothing.
That was hard to add.
What?
That's probably hard to add, most likely. I didn't know what I was doing.
Well, now you do. Get at it.
I think I'm on. Sorry. Yeah.